Welcome children to our third class of mathematics. I'm Ruby Sharma and I'll be teaching you today estimation or rounding off. Now, why do we need to estimate? In general, there are many situations where we need the exact number as an answer. But in certain situations, we need a rough estimate, and sometimes it is not even possible to get an exact number. Now, for example, the monthly household expenditure, or the number of people attending a political rally, or the number of guests who will attend a celebration at your home, and so on. There are so many situations where the exact number is not possible. So let us learn about how to estimate. Now, when we do rounding off to nearest tens, this is called the closest estimate we get. Now, suppose you have to round up 32. So let's take a part of the number line. A 32 is in between which two tens place? 30 and 40. 3 tens and 4 tens. And in the right hand side, you can see for rounding off to nearest tens, you have to select the number and find out between which two tens place it lies. So 32 is in between 30 and 40. And it is convenient if we can find the midpoint. So 35 is the midpoint and 32 lies on the left hand side of 35. That is, it is closer to 30 than 40. So we say 32 is rounded off to 30. Now if we have to round off 79, so 79 is in between 70 and 80. So why we are taking a part of the number line? Because the number line starts, a whole number starts from 0 and it continues till infinity. That is not possible for us to draw the whole number line. So we select that part from 70 to 80 now. That part of the number line. Then find out the midpoint, it is 75. The midpoint helps us to find out. Now 75 is the midpoint, so we will know 79 is on the right hand side of 75. So it is closer to 80. So 79 is rounded off to 80 when we have to round off to nearest 10 or estimate to nearest 10. Now in case of big numbers like 2934, so we just check 34 is in between which two tens place. So 30 and 40. So we take the whole number 2934 will be in between 2930 and 2940. Accordingly, we find the midpoint and find out where 2934 is. So it is closer to 2930. And so it's rounded off to 2930. Similarly, 15 is between 10 and 20. And it is rounded off to 20. Now when we have 2 is between 0 and 10. 5 is the midpoint and 2 is on the left hand side of 5. So it is nearer to 0 and hence 2 is rounded off to 0, nearest tens. So when we estimate 2 to nearest tens, we get 0. Now here we observe, we'll find that 0, 1, 2, 3, 4, all these will round off to 0. And 6, 7, 8, 9 will round off to 10. Now suppose we have 5 here. 5 is the midpoint. So according to convenient, like the whatever we are following till now, that it is rounded off to the higher number. That is 5 is rounded off to 10. Next is round off to nearest hundreds. So we have 47, 40. Now here, see on the extreme right hand side, you'll find the numbers between hundreds. I've written down 0 to 100, 100 to 200, like I did in tens. So 47 is in between which hundreds? Between 0 and 100. And the midpoint is 50. So we observe that 47 is closer to 0 than 100. So it is rounded off to 0. And if you observe here, all from 0 to 49, all numbers will be rounded off to 0. And from 51 to 99, all numbers will be rounded off to 100. And 50 also will be rounded off to 100. So similarly, we have 2566. So here we check it is in which 200s place, between which 200s place, that is 2500 to 2600. Then we find the midpoint and we see that 2566 is between in the right of the midpoint, that it is closer to 2600. So it is rounded off to that number. Similarly, we have this 149 is rounded off to 100. So accordingly, I've already told you 1 to 49 is rounded off to 0 and 51 to 99 is rounded off to 100. Similarly, we can estimate to nearest thousands. So 2401 is in between 2000 and 3000. So we find the midpoint and we see that 2401 is closer to 2000. So accordingly, it is rounded off to 2000. 53,552, number B. So here, what do we check? We are going to check the number in between which 3,552 lies, the thousands place. So it is 53,000 and 54,000. And we find the midpoint. And we find that 53,552 is closer to 54,000. Hence, it is rounded off to that. And similarly, we have all numbers from 1 to 499 are rounded off to 0. And 501 to 999 are rounded off to 1000. And 500 being equidistant from both 0 and 1000, it is common practice to round off to the greater one, that is 1000. Now here a number. Sorry, here's a number 75,847. And we have to round off to tens, hundreds, thousands, and 10,000. So when you round off, you find these are the different rounded form. 75,850 is rounded off to tens, 75,800 to hundreds, and so on. So what do we observe? The closest estimate that we get is 75,850. Now here I just want to tell you that there are no rigid rules when you want to estimate the outcome of numbers. Like there's no right or wrong to which you are going to estimate to tens place or hundreds place. Sometimes the closest estimate is better. Sometimes for easier calculation, we do it to maybe hundreds or thousands. So the most important thing is how sensible the guessed answer would be. Now what I taught you was using the number line, a part of the number line. But we have some other rules. Alternately, we can also round up without using the number line. Now here is estimating a number to the nearest 10 without using the number line. What do? When we have to estimate to the nearest 10, we consider the ones digit. If the ones digit is between like 1 and 4, 1, 2, 3, or 4, then we write 0 in the ones place and the tens place number is written as it is, remains unchanged. The tens place digit remains unchanged. But if the ones digit is 5, 6, 7, 8, or 9, then we have to add 1 to the tens digit. I've given you some examples here. I've shown you with the help of some examples. Now suppose you have 24. Now the ones place will always be 0. And since the number of digit 4 is less than 5, so we do not add 1 to the 10th digit. We write down as it is, that is 20. But in the next question, 78, the ones place is 8. That is, if it is 5, 6, 7, 8, or 9, we add 1 to the 10th place digit. That is 7 plus 1, 80. Similarly, we have 4,556. If we have to round off to 10, we have to check the ones digit. And ones digit always will be 0. You know, as you have seen in the number line, isn't it? It is always in groups of tens, multiples of tens. So we write 0 there. And since 6 is greater than 5, like if it is 5, 6, 7, 8, or 9, we know we have to add 1 to the 10th digit. And accordingly, I've added 1. So we get 4,560. Then 799, it is when we have to round off to nearest 10, we get 800. Now suppose you have to estimate a number to the nearest 100. So here, what do? We consider the 10th digit. The ones and the 10th digit will be 0. So if the 10th digit is 0, 1, 2, 3, or 4, we bring the 100th digit as it is, on whatever digits before that. But in case the 10th digit is greater than or equal to 5, that is 5, 6, 7, 8, or 9, then we add 1 to the 100th digit. So 6,404 will be 6,400 nearest 100. 53,552. You see why I have added 1 to the 100th digit? Because the 10th digit, the highlighted digit, is in the 10th digit, which is 5. So we add 1 to the 100th digit. And we get 53,600. Similarly, we have for 1,000, estimating a number to the nearest 1,000. So here we have to check the 100th digit. If it is less than 5, then replace the ones, tens, and hundreds digit by 0, and the thousands digit remains unchanged. If hundreds digit is greater than or equal to 5, then ones, tens, and hundreds digit will be 0, and we have to add 1 to the thousands digit. So I have done it similarly. 53,552. You have also done using the number line. We got 54,000. And now 613. In this case, you see, all the ones, tens, and hundreds digits are 0. But the hundreds digit is greater than 5. So what do? We have to add 1. And there's no digit in the number, but we know that it is 0. So 0 plus 1 gives you 1. Now similarly, number C, here also we have the last 3 places 0, and the hundredths digit is 2, which is less than 5. So we do not have to add 1. So finally it is rounded off to only 0. So similarly, we can continue this method to estimate to nearest 10,000, lakhs, and so on. Now estimate using general rule. When we say general rule, it is not necessary that we have to have any hard and fast rule. Usually we take the better estimate as the general rule. Now here, for sum and difference, it is better to use we estimate both the numbers to the same place. When we have the same number of digits, like 730 and 998, we see both have 3 digits, 3-digit number. So in that case, it's not a problem. We estimate up till hundredths place. And one thing we have to observe is that in addition and subtraction, both the numbers are estimated to the same place. So here, rounding off to nearest 100, we have done this. 730, 700, and 998 is 1000. So you can estimate using any rule, using number line or without using number line. And the estimated sum is addition of the rounded off numbers, that is 1700. Similarly, your estimated difference you have here also, you have to round off both the numbers to the same place. So here also, since both a 3-digit number, and we see 796, so 700ths place, so 1s, 10s, hundreds, and 300. So we round up both to hundreds. Now estimate the product using general rule. Now for estimating the product using general rule, generally we round off each number to its greatest place. So 578 into 161, both are rounded off to 100 in this case, and you get the estimated product. But in case you have to multiply 1291 and 592. So what do? We round off 1291 to nearest 1000 and 592. You have it till hundreds place, 592, that we round off to hundreds place. And then we find the product. Similarly, we have 9250, we generally round off to thousands place, and 29 to tens place, because 29 to tens. So tens place, and we get the estimated product. But in case the number of digits are different in addition and subtraction, then what do? We take the smaller number and find out its greatest place and round off both the numbers to that place. Suppose you have to add 12,560 and 756. So we'll round up both to hundreds place and then add or subtract. So I hope you have understood the estimation. You can practice the given sums. I'll get back to you soon. Bye.